I am currently at the OP Shenandoah Park. It's mainly has like multiple trails where people exercise. It's not like an excursion or somewhere where people normally go to see nature, but it is really nice. Other than this project, I've been here a couple times for this project, personally 3. But yes, I'm gonna take this long trail and then I'm going to sneak off to those little ones in order to find some rocks. So I do often go in this trail, and before I was specifically looking for types of rock, I didn't know that this rock specifically, well, all of this row is limestone. The breakage of limestone typically retains the color and the mineral composition of the unbroken rock, allowing for easy identification and classification. As you can see, it is light gray with some white spots. In some spots, it also has a yellow brownish tint to it. Limestone also often breaks along natural lines or fractures. As you can see right here, it does have multiple fractions within the rock. These fractures can be either parallel to the bending planes of the rock or at different angles, contributing to the overall texture and appearance of the broken surface. So this is a type of weathering, and there is multiple of these going down the trail. Like I said, this park has a lot of limestone in it. This is one of my favorite parts because it's very open and it has a lot of big trees. But for example, this is all limestone as well. You can tell by the breakage. If rainwater falls, it will start flowing. And all of this, as well as that, would also be considered limestone and chemical weathering. So I came to the bottom to show you a better view, and this is a sign of chemical weathering. You can tell by the cracks and the broken fragments. When rainwater falls and starts absorbing the carbon dioxide, it will slowly start dissolving the limestone as well. I can tell because some of the rocks are becoming smoother than others. For example, this one right here is way smoother around the corners and edges compared to those, or even compared to this one right next to it. Okay, so here we do have gravel. Gravel is a loose aggregation of rock fragments. Let me come a little closer. The gravel typically consists of crushed or naturally weathered rock fragments. It normally contains granite, limestone, basalt, and sandstone. Gravel comes in different shapes and sizes. Weathering does plays a direct role in reducing the size of gravel particles over time, as gravel is very exposed into the environment. Both physical and chemical process acts on the rock fragments, gradually breaking them into smaller and finer particles. For example, let me show you right here. There are different sizes. This one I would consider a small one. This one a very small one. Let me find one gradually bigger. And then this one can be considered gradually bigger. And they all are across the park, especially where the limestone were. There are a bunch of pieces throughout there too, and that can also be because it does contain different types of rocks within the gravel. Okay, so this is pretty heavy, but this is a lime mudstone. It is really cool. It shows clear evidence of dedication cracks, suggesting that it originally formed in a shallow water environment, which it is very possible because during raining storms, like there's tidal flats here, and where lime-rich mud dried up and cracked before lithification. So here's what it looks like. You can see the cracks, and it is very pale compared to limestone. And this one is called a lime mudstone. But I am a big hiker, and this project made me realize that there are a lot of key components that happen in order for rocks to look a certain way, and that a lot of it is involved with chemical weathering and decomposition and weather and rain. And thank you, and I will be on the lookout next time I go hiking.